All right. So everybody has this motion graph paper either now glued into your notebook or you've put it into your folders. Lots of us have it laying on our desk to use for today, and that is fine. We realize that we have 4 different kinds of motion graphs that we're going to see on the test and on the benchmarks, and we have 3 different kinds of speed graphs that we're going to see. And we're going to kind of go back through the introductory lesson that we gave because first class, a little bit of struggle. Second class, holy cow. And usually you guys fall right in line with the second class. So we're not even going to bother doing the lesson that I did in the first class. We're going to do a review lesson, and then we will jump into what we did in the first class tomorrow, and hopefully we'll be ready to catch up. But again, I have 4 different things I'm going to look at with a distance time graph. If the line is horizontal on a distance time graph, it is at rest. If a line moves up, there's no curvature in this line. That is going to be constant speed. Now, when you notice that one line is steeper than another, and they're comparing the 2 objects, the line that's steepest, the line that's closer to the y-axis is the faster object. We might get to see that question today. And you'll see this curve line. There's only one curved line in all 7 graphs. If you see the line curve up, it means it is accelerating. If it starts to curve downward, it is decelerating. Not very hard on those 2. You'll notice right here with the speed and time graphs, this graph and this graph here look exactly the same, correct? Minus one thing, the word on the side. The word on this side says speed. Well, if speed never changes, like if you're going a speed other than 0 miles an hour, you are moving. You are not at rest. That would be constant speed. This one and this one look exactly the same. In this one, it's called constant speed, and here it's accelerating, which makes sense. Notice that speed would keep going up as time goes by. That means you're getting faster. This last one, in the first graph, if we drew this, it means it's going back to the starting point. In this one, it means it is decelerating. The object is decelerating, slowing down. And you'll see down here the way that you can see all of those movements sometimes inside of graphs. All right, as we introduce the graphs, it is very important, and I've realized today, Isabel, that some people did not pay attention in math when they first learned graphs, and they did not pay attention in graphs this year, and they haven't paid attention in science this so far because they're graphing things very weird. I'll show you some of their examples here in just a moment. I know that this is the origin. It does not have to be the starting point of all of my graphs, although typically most of your graphs, most of them will start there. It is possible to start somewhere else because what if I don't start at home? What if I was drawing a graph and like I was trying to get home, but I was already up here at the store? It's going to be different. So again, y-axis is where the speed goes because this is a speed time graph, and down here is where the time goes. I'm not going to do that. Now, I need you all to pay attention. This is where my class was making a majority of their mistakes. See if I can do this in red, but let me change to red, please. Yes, it will. That's close enough to red. All right. When they were graphing this, I know that this is the y-axis and this is the x-axis. I should be going in the door and up the steps, right? In the door and up the steps. So it should be going in 1 and up 5, 2 and up 5, right? But what I noticed people were doing was they were going 5 to 1, and then 5 to 2, 5 to 3, 5 to 4, and then obviously 5 and 5 are probably going to overlap. And it looked like this is what their graph looked like. Well, if you do it backwards, yeah, you're going to get it wrong. However, it should look like this. This is my y-axis. It's terrible y, but drawn with a mouse. X-axis down here. So you should start with X and then go to Y. I go in the house 1 and up the steps 5. In the house 1, up the steps 5. In the house 2, up the step 5. In the house 1, 2, up 5. In the house 3, up the steps 5. 1, 2, 3, 1, 2, 3, 4, 5. In the house 4, up 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 5, 5. That's where that's going to kind of cross together there. And then 6, 5. Now, with this one, I can see on my chart, and I can see over here, does the speed ever change? No, this object is going, let's call it 5 miles an hour every time that I look at it. Well, if my speed never changes, and I know that I have a graph that looks like this, I see that, but if I'm going 5 miles an hour, is there any way that I'm at rest? No, I'm going a constant speed. So you have to be careful how you graph these numbers. Then you have to be able to read the graph appropriately. Again, if you need to reference back, will it go back or not? Like go backwards. There we go. Trying to get it to go here. If you need to go back and reference this, by all means, reference this while we're doing the project this week, while we're working on questions in class. Go back and reference this because it's going to be very important that you're able to do that as you're looking at these. All right, let's look at a different one. Again, I know that this is my y-axis. I know that this is my x-axis. And if I graph this, it's x, y. I go in the house and I go up, right? So that's the first thing you have to do on all of these. So we'll try a different one. All right. So again, first thing I'm going to do, what kind of graph is this? Speed graph. I know that this is the y-axis. I know that this is the x-axis. I'm going to graph it as such, x and then y. In the house, up the door 1. In the house, up the door 1. In the house 2, up the steps 2. 1, 2, 1, 2. In the house 3, up the steps 3. 1, 2, 3. 1, 2, 3. In the house 4, up 4 steps. 1, 2, 3, 4. 1, 2, 3, 4. Are you starting to see the pattern? 5 and 5. 5 and 1, 2, 3, 4, 5. Now, I look at it says that this is constant speed. Did I do that correct? Look at where I'm looking. I am? What kind of graph am I looking at the top of my paper? That is a what? Is that the one I should be looking at? No, because that's why, that was the whole purpose of me saying, what kind of graph is it? You can't come up here and look at this. Now, do you understand how children make this misconception? Do we understand how 5th graders make this misconception? They look exactly the same. But I know that this is a speed time graph. I'm going to come down here. This one tells me that my object is what? Acceleration. Let's see if that makes sense. It's going 1 mile an hour, then 2 miles an hour, then 3 miles an hour, then 4 miles an hour, then 5 miles an hour. Is the object getting faster? Yes, it is accelerating. Not a big deal. Skip over that. All right. Same thing. What kind of graph is this? This is a speed time graph. Speed is on my y-axis. Time is on the x. I go in the door, and then I go up the steps. In the door 1, up the steps, what is that, 8? In the door 2, up the steps 6. 1, 2, 1, 2, 3, 4, 5, 6. In 3, up 4. In 3, 1, 2, 3, 4. In 4, up 2. In 4, up 2, 1, 2. and then N5 up 0, N5, and I go nowhere, and now I notice that my line is doing this. Okay? It's a speed graph. I look at this, I come to speed. There's only one of them where the line is going down. Adley, what is it called when the line is going down? This object is supposedly deceleration. Now, what is the way that we would label deceleration? How would we call, what would we say? We wouldn't say deceleration. You're not going to get in the car today or the bus and like, oh, we're decelerating right now. What would you say? We are what? We are slowing down. I wonder why we're slowing down. Decelerating. Now, let's see if this object is slowing down. 8 miles an hour to 6 miles an hour to 4 miles an hour to 2 miles an hour to 0. Did they slow down? How would you make a car slow down? How would you make a car, bicycle, go-kart, moped, scooter slow down? It is friction, but you would hit the brakes. You're correct, friction. Now, again, remember, we have to tell what kind of graph this is, otherwise we're not going to get this correct. We've changed. Now we're looking at a distance time graph. Distance is still on the y-axis, time is on the x. So x-axis here, y-axis here. I know that looks like an x. I'm going to figure, or y, there we go, x there. Now, in the door 1, up the steps 5. In 1, up 5. In 2, up 5. In 2, I go up 5. 3, 5, I'm starting to see the pattern here. 4, 5, okay, I think I've got it. 5, 5, and 6, 5. Yes? So that was a good question. Like, do you still graph it the same? Yes, graphing it is going to be the same. However, what this means is completely different because earlier we saw that that meant constant speed, right? But that's not what kind of graph I have. Every time I look at this object, it's standing at 5. It could be 5 of these squares in the room. It could be 5 miles down the road, right? So if you pull up Waze and you're trying to see if somebody's coming to pick you up because they said they're on the way, and you realize every time that you pull them up on Waze, they're sitting in the same spot. Are they moving? No, they are at rest because look, this is a distance time graph. I have to move up to here, which means this car is not moving. So this would be at rest. Okay. Whoops, I went too far. Can I go back? There we go. All right. Now, distance time graph. This is going to be very different. This is my y-axis. This is still going to be my x-axis. X, and then Y. N1, up 1. N2, up 2. N3, up 3. 1, 2, 3, 1, 2, 3. I'm starting to see the pattern. In the house 4, up 4 steps. 1, 2, 3, 4. 1, 2, 3, 4. 5 and 5. I've got the pattern now. 6 and 6. I see it. I connect those lines. Now, earlier, this meant that the car was getting faster and faster, right? Notice this is not speed. Speed is distance divided by time. Well, 1 divided by 1 is 1. 2 divided by 2 is 1. 3 divided by 3 is 1. 4 divided by 4 is 1. 5 divided by 5 is 1. And 6 divided by 6 is 1. Every time I check the speed of this car, it is going 1 mile a minute. Or whatever it would happen to be on here. It's not moving very fast. Well, it's moving about average speed. But has the speed, is it speeding up? Is it slowing down? It's staying the same speed, and we said that when you stay the same speed, it is, well, I didn't mean to mark it out, but constant speed. When stop.